I am Mustafa Altın from Bingöl University, Turkey. Firstly, I would like to thank you, Symposium Organization Committee. I will start with weighted minimal translation surfaces according to semi-symmetric connections in Euclidean and Minkowskian three-space weak density. In this paper, we define and classify weighted minimal translation surfaces according to a kind of semi-symmetric metric connection and a kind of semi-symmetric non-metric connection in Euclidean three-space and Minkowski three-space with density EAZ. For partial X, partial Y, partial Z, the standard basis on Euclidean three-space. When Wang identified spatial semi-symmetric metric connection and semi-symmetric non-metric connection, this here, where G1 Euclidean metric. Are you hearing me?
Yes, we can hear you.
My screen. Burada donuyor hocam. Burada donmuş.
Dear Professor, are you hearing me?
I opening 1 minute.
Okay, share your screen, please.
One, okay.
At the bottom, green button.
Okay.
Your presentation, selecting. And
Are you
full
hearing
screen,
me?
please. Full screen, please.
Okay.
Control L maybe is okay. View.
Okay.
Perfect. You can continue.
I am sorry. For the connection, semi-symmetric metric connection of Euclidean three-space non-zero derivatives are given by here. For the semi-symmetric non-metric connection, Euclidean three-space, the non-zero derivatives are given by here. Similarly, for the Minkowski space, semi-symmetric metric connection here, semi-symmetric non-metric connection here, where G2 Minkowski metric. For the semi-symmetric metric connection, the non-zero derivatives are given by this. For the semi-symmetric non-metric connection, the non-zero derivatives are given by. Furthermore, manifolds with density or weighted manifold are very popular recently. In this context, first Gromov has introduced the notion of weighted mean curvature or P-mean curvature of an in-dimension hyperspace on a manifold with density E field as this. Here, P is density function and and is unit normal vector field, H mean curvature of hypersurface. In this study, we will divide three types of translation surfaces which are defined by type A or type B or type C. In this session, we classify the type A, type B, and type C translation surfaces with zero weighted mean curvature according to semi-symmetric, metric, and semi-symmetric non-metric connections in Euclidean tree space with density EAZ, where A is real number different zero. Firstly, we consider translation surface of type A in Euclidean tree space with density EAZ parameterized by this surface. For this surface, unit normal vector fields, first fundamental forms, and second fundamental forms, this here. Thus, the weighted mean curvature of translation surface of type A in Euclidean tree space with density EAZ is given by this equation. For HP is zero, we have this equation. Now we will solve 8. Firstly, let us assume 8 is minus 2. On this assumption, from 8 we get this equation. The left side of equation is a function of S, while the right hand side is function of T. Does there exist a constant C1 such that second derivative f this equation and second derivative C is here? For C1 is 0, we solve the equation 10 this like this, and C1 is not 0 like this. We can write following theorem. Weighted minimal translation surface of type A according to semi-symmetric metric connection in Euclidean tree space with density E minus 2Z can be parameterized by this surface and or this surface. Now for E not equal minus 2. Here we have 4 cases. Cases 1, first and second derivatives of f and c and g are different from 0. If we make necessary calculation, we can see that we have no solution. Case 2, let us assume that second derivative f is different from 0 and second derivative c is 0. Second derivative g is 0. In this case, we have this function. Case 3, let us assume that second derivative g is different from 0 and second derivative f is 0. In this case, we have this function. Case 4. Let us assume that second derivative g and f is 0. In this case, we have this is a contraction. So we have no solution in this case. So we have following theorem. The weighted minimal translation surface of type A according to semi-symmetric metric connection in Euclidean 3 space with density EAZ. E is real number different minus 2 and 0 can be parameterized by this surface or this surface. Since we have no time, now we will give the similar theorems for translation surfaces of type B and type C. For type B, weighted minimal translation surfaces of type B according to semi-symmetric metric connection in Euclidean 3 space with density E minus 2Z can be parameterized by this surface and this surface. And theorem, weighted minimal translation surface of type B according to semi-symmetric metric connection in Euclidean 3 space with density EAZ. A is real number different minus 2 and 0 can be parameterized by these surfaces. For type C, weighted minimal translation surface type C according to semi-symmetric metric connection in Euclidean 3 space with density EAZ will be the same type B. Now I want to show our theorems for translation surfaces according to semi-symmetric non-metric connection in Euclidean 3 space with density EAZ. Weighted minimal translation surface of type A according to semi-symmetric non-metric connection in Euclidean 3 space with density EAZ can be parameterized by this surface or this surface. For type B, weighted minimal translation surfaces of type B according to semi-symmetric non-metric connection in Euclidean 3 space with density EAZ can be parameterized by these surfaces. For type B, for type C, weighted minimal translation surface type C according to semi-symmetric non-metric connection in Euclidean with density EAZ will be the same type B. Now let me give the weighted minimal translation surfaces of type A, B, and C according to semi-symmetric metric and semi-symmetric non-metric connections in Minkowski 3 space with density EAZ. Weighted minimal translation surfaces of type A according to semi-symmetric metric connection in Minkowski 3 space with density E to epsilon Z can be parameterized by these surfaces. Weighted minimal translation surface of type A according to semi-symmetric metric connection in Minkowski 3 space with density EAZ. A is not 0 and 2 epsilon can be parameterized by these surfaces. For type B, weighted minimal translation surface of TP according to semi-symmetric metric connection in Minkowski tree space with density A to epsilon z can be parameterized by these surfaces. The different A is not 0 and 2 epsilon. The theorem. Semi-symmetric non-metric connection with density E AZ tape A for tape A in these surfaces. Semi-symmetric non-metric connection EAZ for tip B. These surfaces. These are my reference. Thanks for your attention.